Yes, I've got too much time on my hands. I'm going to have a little bit of a play in the mill and machine a 12-point bolt head. This is my 3-ton Arbour Press, and as you can see, I've removed the handle and the pinion gear that operates the rack and drives it up and down. That pinion is normally operated by that round lever. I've got the pinion over in the lathe at the moment. Now the problem with operating the Arbour Press with that lever, it's not often in the best position to actually apply the force depending on where the rack is at the time. If the rack's halfway down, the lever might be still too far up, or if you're trying to operate with the rack near the bottom of its run, the lever may be too far down. The advantage, I want to swap it over to a ratchet operated lever, and this old ratchet that I've purchased recently at a farmer's market, it's not quite as long as the round bar there. It's got a 36mm socket at this end. It's a nice spanner made in Japan, RN 32 36, it's 32mm one side. It's got a ratchet, a big heavy ratchet mechanism on it that clicks either side. These are often used by people putting scaffold and things together. I want to use that handle on the end of the pinion shaft. To do that, I could just cut a hexagon on the end of the pinion shaft, but as a exercise, I would like to cut a 12-point star. I've printed this in plastic on a 3D printer, and it fits neatly in the end of that socket. So if I can cut that shape on the end of the pinion shaft, I'm going to reduce the length of the shaft to about this length and have that star shape on the end of it, and a tapped hole in the middle so that the ratchet spanner can be held on there, and then it's adjustable to give you the best leverage at the best point. This is the pinion shaft off my Arbour Press. It fits into the arbor. You can see that's the gear there. It happens to be 18 tooth, so it fit in my 6-jaw chuck with each tooth engaging on a jaw. That's worked quite well in terms of gripping it, and this surface was running fairly true. It's a little bit out of round, but the run out's not that important. I've machined quite a chunk off the end of this. The actual hole that held the main lever bar was where my finger is there, and it's probably about a 3/4 inch bar or 19mm bar. And then the shaft here was around that length. It had a tapped hole in the end to put a bolt in to lock into the 3/4 lever bar. Now I've also machined down about another 20mm or a bit over 20mm of this large diameter down to about 42mm. My aim is to machine in this section here a 12-point pattern like that, which is a 36mm across the flats if it was hexagon, but it's a 12-point star shape that fits inside the ratchet spanner that I've got that fits on here. I've printed this out of plastic on my 3D printer, showing you the sort of size that needs to be, and I've got an engagement of just over 20mm per tooth. This is only 8mm, the sample I made, But I intend to CNC machine a 12-point pattern on here by mounting this up in a chuck vertically on the milling machine and running a cutter around in that 12-point pattern down from this direction, cutting out the shape on this end. This distance here spaces the ratchet spanner that I've got far enough away from the column so that it misses, but moves it in closer to the column than the old 19mm lever bar that was there. So I think I'm going to just drill and tap an M8 hole in the end of this while it's still in the lathe. That may be used later for holding the ratchet spanner onto this pinion shaft if need be, or it's just going to be something that I can do now while it's in the lathe and still running true. I've set this pinion up in a 4-jaw chuck, strap clamp down to the bed of the milling machine. I haven't accurately centered the tool over the center there yet. This didn't have to be set perfectly in the chuck because really it's the alignment will be set up based on where the actual star shape is to be machined. I've got that set next to a vise which is around the center of the table and a rotary table up that end. I've just got enough play. I marked a limit on here as to where that comes to, so I've just got enough movement in the table to be able to move this tool from there across to here somewhere before it would hit limit switches, which is adequate for the job I want to do. I can't mill into a tight internal corner with a round milling cutter, so these holes I'm drilling now are to create clearance on the internal corners. They are actually below the surface of the 12-point star pattern. That's a 7/64 drill, which is about 2.75mm, and I'm drilling into the end of this pinion around 22mm deep. I'm peck drilling, taking it nice and easy. It's only taking around 0.6-0.7mm peck each time and doing a full retract. So it takes quite a while. This is just the third hole. It just moved then to line up for the next hole. It's got a clearance height of 5mm above the top surface there, and I notice it sits and pecks air until it gets down to the zero height, and you'll hear it take its first cut just then, and a bit more now, and a bit more, and it's starting on the process. So this is going to take a little while. I'll add a little bit of lube. Ralphie says that separates us from the animals. It's not cutting fluid anymore, it's lube. So that's starting on the fourth hole, and it's going to take a while to work its way around all of these locations. I've effectively spot faced these locations and put a slight centre drill mark in each of them. I had earlier on chamfered this corner surface and then decided I needed to drill these clearance holes, and that the centre of the hole was going to be right on the edge of the chamfer, so hence the sort of spot face. It'll end up an interesting pattern when it's all machined away. So in the meantime, I don't know how long a 7/64 drill will last. It's a P&M jobber drill, pegging away slowly. It's got 12 lots of over 20 mil to do, so 140 millimeters of drilling. I hope to get that out of one drill. It's doing 3,000 revs, and as I said, it's only packing about 0.6 or 0.7. I've got the feed rate set to about 50 millimeters a minute at the moment, so as I said, taking it pretty easy. I changed out this drill after the 6th hole, thinking, well, if the drill's getting blunt, I don't want to run the risk of shearing it off in one of these blind holes. So I waited till it finished the 6th hole. There's 12 of them in total, and I figured, well, if I change it now, if the drill's not blunt, it'll just go back in the kit. If it is blunt, it may prevent a disaster. So a brand new drill starts the final 6 holes, and I'm fairly confident now that it will finish the process without any problems. So you can see I'm on the 7th hole currently. I'm running a feed rate here at just 52 millimeters per minute. There's my drill pattern there. It's around on this hole. It's going to finish around the remaining there. This current hole, you can see it counts up to minus 15 there. It's got to go to minus 22. And over here, it's in the drill peck cycle, which is the top line there, and it's down currently doing X 13.5, Y minus 13.5, which is effectively a 45-degree angle from the center, which is where this point on the 12 star point star pattern fits. So we'll wait for that to continue. I don't need to interrupt it. I might just add a drop of oil each time it finishes a hole, and you can see it's up to 19, minus 19. It's got about 4 more pecks in this hole, and it'll be finished this hole. I'll come back and watch the movement. You'll see it step over in a moment and start the next hole. Pecking air there. I think the clearance height is 5 millimeters, and it pecks all the way through that 5 millimeters. But they're nice little short pecks of air until it does its first cut on that one. As I mentioned, there's a centre mark in that middle of that faced area there that to pick up on, because these holes, as you saw, are very close to the 44 millimeter diameter section here, which is the outside of the star shape that I'm machining ultimately. For those that haven't seen my Z CNC control on my Bridgeport style mill, this is a 16 millimeter ball screw. There's a ball nut inside this yoke, which is attached to where the normal depth indicator is attached through to the spindle, and that ball screw is being rotated by this little stepper motor, or it's actually a servo motor here, driven with a 2-to-1 belt across to the end of that ball screw. And this is a double angular bearing in this block here, which is screwed up into this flange here. The top of that ball screw is just rotating in I think the 10mm or 3/8 hole, the standard hole that's in the top here. But this yoke was the part that needed a bit of accurate drilling to align, and now that's starting the next hole with very short pecs here, as you can see from that handle. But yeah, a bit of lube in here and up here. These are the limit switches attached that just trigger on the edge of that little, I've put a little tapered block on the side of that yoke, and there's some screws, I think some screws holding that ball nut to that yoke. There's a couple of little notches at the bottom of the ball nut flange so that it sits low enough in that groove to run on that 16mm ball screw. The hole in the end of this grey end part was the standard 16mm or maybe 5/8 hole that comes standard on the mill. So the ball screw that I ordered was a standard length, and it fitted in that hole, and it was a little bit tight in the top there, but I've got videos on my YouTube site showing how that was designed and came together, and it works, as you can see, pretty damn well. You'd think maybe just drilling a tiny hole like this is not requiring a lot of torque to wind that up and down. Well, I've had much bigger drills being operated in milling cutters and ball end milling cutters running 3D programs on this mill in this configuration. I think that's a 200 watt servo, and as I said, a 2-to-1 reduction, which just misses the quill. I've got this LED ring light cut to fit in there as well, and as you can see, it all works very well. So I'm almost finished this row of holes. You'll see the Z counting up to got up to -17. It's got to go to -22, and then there's one more hole to go. That's all my 12 holes drilled successfully. The deep drilling, 22mm deep, and it's only a 7/64th drill, or around 2.8mm. So that's been a successful operation. That's taken a bit of setup and a bit of trial and error. I had errors with the G-code initially, and now I've got it sorted and I can go on. Those holes create a clearance hole on the inside point of the star, which I can't get a milling cutter cutting in this direction into. So hopefully that helps and it all works out. In part 2, I mill the star pattern out. Get out to your shed and have some fun.